welcome to another episode of Measurement and Measurable. In part 3, we will be discussing significant figures. However, to keep the length of the video short, we will again split this into two halves, and this is the first half. So what are significant figures and why are they useful? The fact is, now that we know that all measurement contains some sort of uncertainty, we must find out a way to represent the data or tabulate the data so as to convey the information regarding the precision of the measurement. That is the uncertainties we had. Notice that a portion of our measured value is always certain. For example, we take a meter scale which has a measure graduation at 1 centimeter interval, and each of these intervals are further divided in 10 parts. So the smallest division is of 1 millimeter. We often call this least count. Now, when measuring something, we find that one of its ends coincides with the 0 of the scale and the other end falls between 12.3 and 12.4 centimeter marking. Now, we may mentally estimate and write down 12.36 as a result. Here, the digits 1, 2 and 3 are certain, but 6 is doubtful. As we already know that our measurement is more than 12, our measurement is also more than 12.3, but we are not sure how much more because it doesn't match with any other marking, and it can very well be 3.7 or 3.8 or 3.5. Notice, however, that 4 of these numbers or digits are significant in this particular reading. The leftmost number, that is 1, is the most significant one, and the rightmost number, that is 6, is the least significant figure. Note that you are actually encouraged to guess the last digit of the measurement just at looking at the scale. Now, we define significant figures as the digits that are known with certainty plus an additional digit that contains some uncertainty in the measurement. However, we need some standardized rule to talk about significant figures. Let us see why. For example, consider some length measurement. We have tabulated the result, and these are the result. Now, looking at this figure, the last one, that is 0.00424, appears to be very precise. However, someone else might have tabulated the data with a different unit system and came up with this reading. See, it is still pretty much precise, this 2.4 thing. However, the precision levels appear to have changed. Here, on the other hand, it was 100 centimeter, it is 1 meter. So, if no other information is given, we are not sure what was the scale marking, what were the least count of the scale, and how much precise they are. So, what does significant figure say? Significant figure rules say that if nothing else is given, then the first reading contains 3 significant figures, second one 3 significant figure, and the last one amazingly contains 2 significant figure only. We'll come back to the second reading, which we now say that 3 significant figures are there, but we will see later that in this sort of reading, if nothing else has been said, it is safer to assume that there is only 1 significant figure. The amazing thing about the third reading is, although we have measured something up to 4 decimal places, at least it appears to be so, we say that only 2 significant figures exist here. So confused, let us decode the significant figure rules. Firstly, notice that there are some confusion if zeros appear at the end of the number. For example, if a measured value is quoted as 700 millimeter and nothing else is known, we know nothing about the smallest division of the main scale. If the scale has only meter marking, then the digit 7 is itself doubtful. Consider a scale which has a 0 marking and 1 marking. It's a meter scale and some reading is definitely more than 0.5, that is crosses the half mark, but you are not sure what it is. Someone says it is 700 millimeter, it may very well be 750 millimeter, and it may very well be 800 millimeter. You have no idea because there are no marking. So this figure 7 itself becomes doubtful. However, had it have a centimeter marking, then situation would have been different. Up to this point, you would have been certain, and only doubtful figure would have been the last 0. Now let us understand this with the aid of 2 different scale. The first scale contains only the major marking, while the second scale has minor markings as well. So if we measure the same object with the first scale, here is the measured value of the first scale, which lies between 4 and 5. and it is very near to 5, so we may safely guess that the result is 4.8, but you are free to guess 4.7 or 4.6 as well. The main thing is this 8 is doubtful. On the other hand, when you are measuring it from the second scale, you are sure that it is somewhere here, so it lies between 4.8 and 4.9, so you may safely guess like 4.85. Someone else would have guessed 4.86. It doesn't matter. The important thing is the doubtful figure here is 5. So while the first reading contains 2 significant figure only and the second reading contains 3 significant figures, it is more precise. So what are the rules? The formal rules are like this. All non-zero digits are significant. So for example, 4.7 contains 2 non-zero digits and there are 2 significant figures. Zeros between significant figures are significant. For example, 706, 7 is non-zero significant, 6 is non-zero significant, so the 0 in between them is also significant. Then zeros to the left of the non-zero digits are not significant. So for example, this reading 0.002047, these 3 zeros are at the left of the significant figure 2, so they are not significant. Finally, zeros at the end of the number are only significant if they are to the right of the decimal point. So consider 2 examples. For example, 100, we talked about such thing in an earlier slide. Since it has no decimal point, these zeros which are sitting right to the non-zero figure are insignificant and it has only one significant figure. However, in this case 0.0020, these zeros 0.00 are at the left of the not significant figure 2, but since it contains a point, the 0 sitting right of the significant figure 2 is significant. So there is a non-zero digit and this 0, ultimately significant figures are 2 here. So these are the rules. So how to write down significant figures? Now that we have identified significant figure, how to actually write it down? Suppose you have a reading of 700 millimeter and you know that all 3 digits are significant, that is the last 0 only is the doubtful figure. So what you do is you write down 700 and you put an underbar on the last 0. It is a standard notation. However, a better notation is the scientific notation, where you write down the significant figures in terms with a decimal point 7.00. Remember, this is the non-zero digit, it is significant, and these zeros are sitting right of a non-zero digit and contains a point, so these are also significant. So it suggests that 7.003 figures are significant into 10 to the power 2 millimeter. It has an additional advantage. Suppose you want to change the unit, you just adjust the power of 10 and you are done. So this is the summary. We'll meet again in the next episode of significant figure, where we discuss if you have 2 different significant figure, how to add up these numbers, how to multiply them, or how to take the ratio. Meanwhile, you can do your own research. Every scientific calculator comes up with a scientific notation option. If you have one, find out how it works. Till next part, it's goodbye.